Thank you very much for the invitation. For me, it's really a great pleasure to be here and to have the opportunity to talk to you. When Matthias Baum wrote about some weeks ago, asked me whether I wanted to speak here in front of you, I said yes, and I didn't know anything about IWAMA. So my first step was to look it up on the internet. An amazing project, and you can be very proud that you found together to work in the wastewater sector for the Baltic Sea region. And then I thought, oh, you know so much, what can I contribute? And so I've decided to tell you something about water and energy out of a German point of view and from a point of view German association has. Firstly, I would like to talk or to introduce you to DWA a little bit and to DWA and energy. Secondly, I will tell you something about our standard DWA A216. It's our standard about energy audit. But I have already seen on the internet that you know a lot about that, and here are lots of practitioners who already carried out energy audits. And then thirdly, in the end, I would like to talk about our typical German research project about energy efficient water management, and the abbreviation is ARWAS. Okay, let's start with DWA and energy. And I have found out that you already know DWA because you had the presentation, I think, in your second workshop in Germany. Now, let me please just repeat some things. DWA is a non-governmental, non-profit organization. You see? It represents the specialists that are active in the field of water management, wastewater and waste. And DWA's activities are politically and financially independent. And DWA deals with technical scientific topics and economic and legal issues of environmental protection. And one of the main tasks of DWA is to elaborate the standards and rules in the wastewater sector. Maybe you had one or the other. Some of the rules are translated into Polish, some or many are translated into English. So, and now me, I haven't introduced myself yet. My name is Annett Baum, and I work as a technical officer in the staff unit research and innovation. And so I was really thrilled about your project, as one of my main tasks in this research and innovation is the coordination of themes concerning energy and research. And so I think, oh, it fits, and we should get into contact and communicate, as it's your task. So, and what are the tasks of research and innovation at DWA? Of course, similar to your project here, it's networking, information and communication. We have developed a DWA information system on energy, but it's only in German, I'm sorry to tell you, but you can find it on the internet. We have annual meetings, DWA events, we call it Energy Days, and you are invited to come in October. I can tell you more when you're interested. And we have networking and transfer like you do. And one of our tasks is the initiation and assistance for research projects and political consultation. So when you work for a wastewater association, you can ask some questions. For example, what is the trend of energy utilization in wastewater management in Germany? What triggers German municipalities to save energy in wastewater treatment? And what is the role of a German association in this area? I will try to answer these questions. First, when I thought about the talk today, I thought, what can I say? What is important? And so I find something on the net from our German federal government. It said, if we had two Earths, what we could live like that further on. But we only have one Earth, and let's shape it. And I think that's the way wastewater treatment plants think as well. And today, during your meeting, is the International UN International Ocean Conference in New York. It fits really well. And tomorrow will be the International Ocean Day. So you have really chosen the best day you can do for your project. So we found out wastewater, the increasing energy costs. You know lots about decreasing fossil energy resources, decreasing of non-renewable resources, and of course climate change. And I think we have to do a lot internationally. Water is really a big key for adaptation, and energy a very big key for climate mitigation. And we always say no water without energy, and no energy without water. And my personal credo is that wastewater holds resources that can help us to find solutions for some of the world's most pressing problems. And I think in the future, wastewater will be thought much more in the system as it has been some years before. And maybe this slide is for documentation and for the file, you can find it afterwards. I would like to say something about the German water sector. Maybe you already know it, as it's a very big aim to save energy, to increase energy efficiency, and to develop renewable resources. So some numbers or some figures. Germany has 10,000 municipal wastewater treatment plants. It's very easy to remember, I always do. And more than 97% of the wastewater is treated. And maybe it's interesting for you to know the last number. Only 14 plants represent more than 83% of the total design capacity for municipal wastewater. The other numbers, you can look them up when you're interested. So, and numbers about the wastewater treatment, electricity, 6.6 terawatt hours. This is for wastewater treatment and drinking water. Wastewater treatment alone is 4.2 terawatt hours. And the heat that wastewater treatment plants use is similar to electricity, but you know it better with seasonal variations. So the energy we use in Germany for drinking water and wastewater, the electricity consumption is as much as you need for a city with 1.6 million four-person households. So we think you can do a lot. And the future maybe will be self-sufficient wastewater treatment plants. So DWA has carried out a research project. We carried it out about 3 years ago, and we found out that the potentials for energy optimization have not fully been realized yet. So the wastewater treatment plants in Germany produce 1.4 terawatt hours per year, and we think, or DWA thinks, that it's only 1/3 of the possible potential. So wastewater treatment plant could triple the electricity production. And that's the reason we do a lot in this field. Secondly, DWA is the standard for energy audit. And DWA has recently 4 years ago, published a standard. It's called Energy Check and Energy Analysis. And it's still only in German available, but it's in the translation process, I can tell you. And I have read on the internet that you carry out lots of energy audits, and you have a special, I don't know, a field, a special focus on energy audits. And maybe you do it, maybe you do it in a similar way. The average energy use, I think it's similar all over the world. You use a lot of energy for biological treatment, and you use a very big part for pumping stations, sewage discharge structures, and lifting stations. It's usually there. The energy check and energy analysis. In this technical rule, I've brought it. When you want to look it up, I have it in my with my information. It's a two-step approach. In the first step, it's an energy check. They have called it energy check. And the second step is energy analysis. The first step, energy check, I think you have done it too. Maybe you don't need the rule, but the rule was made maybe to have a similar approach for everyone. So energy check is the first step. It's just a rough estimation of the energy consumption. And they want to find important performance indicators. They want to evaluate the performance indicators over a certain time span, and they want to find gaps and failures. And of course, they want to formulate what is the need for the next step or for the action. So I have written down some performance indicators for an energy check, and I think you use them, and you already know them. The specific total power consumption, specific power consumption for the aeration, specific production of digester gas, the degree of digester gas conversion into electricity, self-supply with electricity, specific internal thermal requisitions, and the specific power consumption of the pumps. All these parameters are explained in the standard, and the standard will help users who are not very used to energy thinking in the wastewater treatment process. And then I think it's the same as you do in your energy audits, the energy check performance indicator. This needs per population equivalent. And so I think you have average numbers as well, and they range between, you see, 50 and 32 kilowatt hours per population equivalent and year. You say it's not translated yet. I forgot. So when you have carried out step 1, you can come to step 2. It's energy analysis. And in this analysis, you want to improve your energy efficiency, and compared to the energy check, you go more into detail here. And the second step, the energy analysis in this standard, compared to the energy check, this analysis goes more into detail and considers the construction works, the process as such, and the techniques in place and for the equipment. And later on, you will hear a talk about aeration systems, and this is something really important for energy analysis. You really check every single step. Oh, I've lost my pointer. I will finish here. The evaluation process. like all management processes, it's a continuous improvement process. It's like plan, do, check, act. I think you know it very well, and they are ongoing processes, and you always need the evaluation. And then you need criteria to for definition of success. And at the moment, the most important criteria are always economic calculations, but maybe it will change someday. So I've written a multi-criterial assessment. Maybe there are other important criteria in the future. When you have got questions about this standard and the energy check and energy analysis, you are always invited to ask. And now let's start with part 3. It's a research project called Energy Efficient Water Management, and it was funded by the German Ministry of Education and Research. Before I show it to you or I tell you something about this project, I would like to inform you about 3 other projects in concerning the topic of water and energy. One is the first one, UIP. It's a German project. It's called Environmental Innovation Program. It was carried out between 2013 and ended last year. And I have written they had 10 projects. And I've written them all down for you in order to inform you what they were researching in. And when you are interested in one or the other, you can always look them up on the internet or you can ask me. But as you can find out, they had energetical optimization, plus energy wastewater treatment plant, energy generation, energy self-sufficient wastewater treatment plant. So there are lots of wastewater treatment plants in Germany who work in this field. Another project, maybe you are interconnected with them, or on Twitter you have a connection, or in Exchange, is the project Power Step. It's a Horizon 2020 project, and it's an energy positive wastewater treatment plant in your city. And the third one, maybe you have interchange with them. It's the Water project. It's a Horizon 2020 project. And they have a similar aim as our energy standard for energy analysis and energy check. They want to collect data in order to find a very good wastewater treatment way, energy efficient wastewater treatment ways, just in short. And you can look them up on the internet. So finally, let's come to the research project funded from the German Ministry of Research and Education. And the long title is not energy efficiency of wastewater or water management. The long title is future-oriented technologies and concepts for an energy efficient and resource-saving water management. The project, we often say water meets energy, wanted to provide solutions and technologies for managing the nexus between water, resources, and energy, similar to your project. And it was carried out between April 2014 until May 2017. It has just ended. Most of the research projects have now finished, or they are in the finishing process. They had 12 joint research projects, 20 research sites. The ministry paid 27 million euro funding and about 81 project partners. And they had the important research focus were new ways of using the energy potential of wastewater and drinking water, and to create a link between water and energy sector. like you do. And 7 projects were in the wastewater sector, and they were looking for new technology modules for an energetic optimization, integration into regional material flows and recycling processes, elimination of micropollutants. It's a very big theme and very important, I think. Development of biofuel cells. I will tell you, it's a revolution in the wastewater treatment process. And linkage with energy networks and use of management potentials, of load management potentials. Then there were 5 joint research projects in the water supply system. They had energy recovery. They worked a lot of with modeling and simulation, and they were looking for the linkage between energy networks and drinking water, and they wanted to use load management as well. Here are the 12 projects. We have nice abbreviation, not as nice as IWAMA, but similar, from Arrive to Kara and Maverick. And I think I don't want to tell them all. The bold written ones, they are the wastewater projects. So we had treatment plants they had control components in energy grids, microorganisms produce energy, methanol synthesized from wastewater. Then the future wastewater treatment plant was developed, and a wastewater treatment plant as energy service provider, a wastewater treatment plant as energy buffer for power grids, and transforming sewage sludge, it's one of your main projects as well, to energy and phosphoric fertilizer. And now the results. It's very easy, and first they found out water treatment and energy must be connected, as you know already. But then the real revolution is that microbial fuel cells work very well, and they can provide potentials. I will tell you later on. Then they found out what water management facilities provide flexibility components for the electricity market. And maybe you have found it as well. They found out that the socio-economic framework conditions are crucial for system integration and optimization. And mathematical optimization algorithms and easy-to-use optimization processes save energy. These are the results, very in short. And when you have some more concentration, I could inform you about some results in a more detailed form. For example, one project, Arrive, wastewater treatment plant are the control components in the energy grid. When I show you the next slide, you will see lots of sentences. Usually I don't do it in slides, but I did it for your presentation, for your documentation, not for the presentation. When you read it on the internet, you have some more information. It's not for presenting now, but I want to say that Arrive found out that wastewater treatment plants in Germany are capable to provide the needed technical requirements and potentials to interact on the energy sector. And that is really a good result, as in the beginning everyone said, no, it's never possible. Wastewater treatment plants can never interact with the energy sector. The second is Eclair, the wastewater treatment plant of the future. Let's say that one of these, they had a kind of management project, and the aim was to find the real good wastewater treatment scheme for an optimal use of energy and resources, and they wanted to adapt it to the future. So when future changes, wastewater treatment processes must change as well. And so they had a, how can I call it? It's a it's a support system, decision support system for to choose the infrastructure. And it's really interesting. You can look it up on the internet as well. Another interesting project, it was carried out in Darmstadt for the next, well, the next speaker will come from, is the wastewater treatment plant as energy service provider. So one of what's very important to say is that the former approach of improving the efficiency of individual units by energetic optimization is not sufficient anymore and has to be supplemented by a holistic approach on flexibilization potentials. You can read it later. And maybe Kara and Maverick is interesting for you as well, as they tried to transform the sewage sludge into phosphoric fertilizer with a metallurgical conversion process, and it's still a small plant. It's a plant that doesn't function at the moment, but the first research they carried out show that it's possible to regain the phosphoric slag. You can read this later. And then they had very interesting results in cross-cutting issues. So they had working groups in biofuel cells, energy storage, sewage sludge like here, and modeling and simulation. So some more, I would like to repeat it just for the ending. And for you, maybe you can integrate it into your project when you know that bacteria can clean wastewater and simultaneously produce energy. I think that is one of the most revolutionary aims that they found out, and it's really possible. And another is water management facilities provide flexibility components and can take part in the electricity market. Energetic optimization of piping systems and drinking water supply can save energy. And all the information you can find on the internet. And you find events and latest news like on your website. And we Twitter as well. Maybe we can become friends. We Twitter our tweets. And when you like playing on the internet and you like serious games, you find a kind of serious game where you can visit all the projects and can find more information. So, thank you very much for your attention.